Central Andes Mountains, located on the west coast of South America, contain more than 99% of the world's tropical glaciers. Within Peru lies the Cordillera Blanca, the largest glaciated area in the tropics. The region studied in this research is the Huascarán National Park, which encompasses most of the Cordillera. Recession has occurred since the second half of the 19th century, but has increased dramatically in the latter half of the 20th and early 21st centuries. Previous studies have shown a decrease in glacial area by 15 to 20% in the Cordillera Blanca between 1970 and 2003. Though studies have been performed on glacial recession within the park and the Cordillera Blanca as a whole, no research has assessed the patterns in which the snow and ice melts. This study hopes to analyze this issue and determine the directionality or aspect of deglaciation in the park. Prior to beginning the study, it was hypothesized that as the glaciers continue to recede, the ice will melt into smaller pieces, creating more patches and an increasingly fragmented landscape. This fragmentation was expected to increase the rate of recession more so. Classified Landsat 7 imagery from winter months in 1987, 1999, and 2010 were used. Analysis of the landscape within the park was performed using FragStats, a freeware spatial analysis program from the University of Massachusetts. Finally, these measures were compared against aspect in ArcGIS in order to determine in which directionality the glaciers are receding fastest. In accordance with previous research, results showed a decrease in glacial area. However, unlike previous studies which indicated a 15 to 20% deglaciation between 1970 and 2003 within the range, results indicated a 33% decrease in area from 1987 to 2010. Fragmentation decreased dramatically from 87 to 99 and rose slightly between 99 and 2010, opposing the original hypothesis. This likely indicates a reduction of the snow and ice to its core area due to the elimination of small outlying patches between 87 and 99, and a disintegration of the core area between 99 and 2010. Comparison with aspect reveals western-facing slopes have consistently had the most glacial cover historically, though all slopes are decreasing at similar rates. This indicates that deglaciation in the area may not be linked to differences in solar radiation based on aspect, as western slopes would be expected to recede fastest due to the combination of radiation and afternoon heat, but instead changes may be determined by the topography or increases in temperature in the area over time. Overall results showed an expected loss of snow and ice within the park and allowed for a greater understanding of the fragmentation patterns over the selected time period. This study can be combined with research on relative growth and changes of other land cover types in the region in order to give insight into the transitions of the range over time. Further research is suggested in order to predict future evolution of both natural ecology and human landscape interaction. Thank you for watching.